Fox would be from United Kingdom. You are incorporated in the United Kingdom, as far as I know.
That's right, yes.
Okay. So, can you tell a little bit about your company, your activity, and why you are proud of?
It's a waste management and recycling company. I guess the edgier way of looking at it is a circular economy company. We are interested in resources that we can find in waste streams and waste products. So as a company, our objective is to basically take recycling processes and make them cheaper, more profitable, cleaner and more energy efficient. And our vision is to have various industries where the waste products from one particular industry become feedstock for another industry. The sort of models that are inspired by ecosystems, if you will. If you look at nature, it's all about really high growth, really high decay, lots of recirculation, and crucially, it's all about zero waste, because nothing in nature goes to waste. Whereas if you look at human activity, it's anything but. We have industry where we start from one product, we process it, we make what we want, and that leaves behind waste. And our general model for dealing with the waste is to just bury it, dig a hole somewhere and bury it and never think about it again. But all sorts of companies now are beginning to look at waste in a whole other light. And with advances in science and technology, it becomes possible to take this waste and not even think of it as waste anymore. Think of it as a raw material, as something waiting to become a starting material for another process. And ultimately, we look at what's now referred to as cities of the future, people considering what our future cities might grow and look like. And we don't so much think of those as from a zero energy model, but rather from a zero waste. Imagine waste coming in, nothing but waste coming in, and nothing but products go out. And as a company, our platform to where we begin towards our journey is basically the lead acid battery. Mm-hmm. So lead acid battery.
This is where you start.
Yeah. And a lot of that will become apparent later on as we speak. It's to do with where our strengths lie as a company in our backgrounds, basically. But the lead acid battery, I think there is no person in the world that's not touched by that product. You find them in automobiles, in cars. They start the engine, they ignite, and they power onboard electronics. They're used to support telecom towers in hospitals, backup energy supplies for lighting, railways, just about anything. So in one way or another, you've been exposed to the product and you've benefited from the product. And it's an amazing product. It was invented before the mechanical generation of electricity. Before we could generate electricity mechanically, we had lead acid batteries. They used to be powered by something called a Daniels cell, for example. And fast forward to 2018, and the product is still around. And there's very good reason for that. It's in fact the world's best example of a circular economy. There is nothing else that even comes close. Glass, paper, certainly plastic, wood, nothing can be recirculated as economically and technically a marvelous way as the lead acid battery. And the reasons for that are two. One is that lead metal is infinitely recyclable. You can take it through as many recycling cycles as you want. It will not lose its quality or its capacity to do its job. And the second reason is that the economics make sense. And when the economics make sense, then the materials get collected and get processed. Whereas I don't want to divert too much too quickly, but with plastic, for example, the recycling economics don't make sense. And this is why we're good at collecting it, but not recycling.
That was my question. How sustainable, meaning sustainable in economic point of view, how cost effective they are. Because as you said, in plastic, it's not cost effective to recycle.
Yeah. Well, the devil's in the detail. It's the supply chain. The supply chain for the LED is perfect.
Oh, for the LED,
for this. Yeah, and this is exactly why it's such a fantastic product. But although the product is amazing, the recycling process for the lead acid battery is not. It is a very big offense.
The existing.
Yes, the incumbent industry.
Which, as far as I know, is blast furnace, is our smelt furnace, is sometimes it's ISA furnace in pyrometallurgy. All these recycled batteries, paste, all sorts of byproducts from crushing batteries. These industries are saying are not incumbent industries.
They're very good at doing what they do, which is recycling the lead metal.
Yes.
And they've been around for more than 100 years.
Yes.
And again, the reason they've been around is because they're profitable and they're very, very good at what they do. But despite their success in what they do, they are very big. They have very big carbon footprints as an industry. They are not energy efficient at all. In fact, they cost a lot of energy. To put that figure into perspective, it's about 50 times the average the amount of energy you can store in a lead acid battery. You basically need 50 times that energy to recycle the battery through the incumbent processes.
50 times?
Yes. So they're not.
These are calculations you've done yourself.
Yeah. But they're also out there in the literature, and it does vary from smelter to
50
smelter.
times compared to 50 times of what?
The amount of energy you can store in a battery.
Okay.
So as a mean average.
So recycling is 50 times more than the amount of energy you can store in the battery.
Yes, through the incumbent industry.
Okay.
But also they release noxious gases, sulfur dioxide, nitrogen dioxide, which a lot of them, of course, are very good at catching, but gas abatement techniques that are used to mitigate these problems are very expensive. And so you can summarize that by saying they have an energy efficiency and pollution problem, the current industries. And the way that industry works is basically the batteries are taken and essentially they are burned at high temperature. It's typically 1,100 degrees.
Sometimes it's more complicated than that. There is a crushing, there is separation, and then divided in paste, divided in the metallic part, divided in several other things.
Well,
This considered the input.
a battery is made up of several different components. There is plastic, for example, the casing separators. There's a liquid material inside, which is electrolyte acid. And then the lead is in the form of a solid metal, but also a wet, muddy type of lead, which is lead salts. And those are the active ingredients in the lead acid battery. Now, a good smelter would crush them and separate out the plastic, and then they would recycle the plastic.
Well, some they do not. They just use it as a fuel.
Yes. But in any case, the battery, let's call the lead burden. The lead burden will burn.
In one extreme case, they just put the batteries as it is in the blast furnace, doing nothing. Just poof in the blast furnace.
Yeah, they drop them from a height to crack them, they collect them and
No.
drop them in the furnace.
No. They just put it in the blast furnace as it
With the
is,
acid.
doing nothing.
That will be a shocking example of a high footprint, high energy cost, high pollution impact smelter, because the plastic burns and it's never a good thing to burn plastic. It will release a lot of horrible things into the atmosphere, nitrogen dioxide, furans, goodness knows what. The sulfuric acid, the electrolyte, will be responsible for a lot of sulfur dioxide. And my guess is that if a smelter is not sophisticated enough to break a battery and separate components, they will probably not be sophisticated enough to catch the pollutants once they've burned the battery.
Some they do. They do all complete separation. But you have all spectrum.
But even if we look at the very best smelters in the world, the ones who do not pollute in terms of releasing noxious gases, they still have a very high carbon footprint. The amount of carbon dioxide they produce, the amount of energy they spend, they are very, very high, and they can be improved. And this is exactly what we've basically set out to do. Because when the batteries are burned, what you make from that process is a lead metal. It's a nice and clean bar of metal. It goes through a few refining steps, of course, but then you use that as a raw material to make new batteries. And one of the materials you'd want to make is lead oxide. Lead oxide is the active ingredient in a lead acid battery. It forms that muddy substance that we call the battery paste. And the way this is produced is you take the lead metal after you've produced it through the furnace, the burning process, you melt it and you oxidize it again. And the lead oxide then becomes the paste, it goes in the battery, and round it goes. When a battery is dead, it contains lead sulfate, you burn it, you go through the stages.
Should I say the amount of energy you always recycling 50 times the amount of energy that you can save in the battery?
Yeah, as a mean average.
And with your new technology?
It's closer to 1-to-1. I think the figures are that it's about, at worst, we are twice that amount. So it's more like between 1.5 to 2 times the amount of energy you can store in a battery. But
this is hydrogen energy route.
That's right. So what we do essentially is we take that muddy paste and we recycle this in water rather than in fire. So we don't burn it in a furnace. We do a process in aqueous phase in what we call a leaching tank, which is basically full of water, and the chemistry happens in the aqueous phase. So automatically that takes you away from the hot furnace, and that means lower capital costs. The money you spend on the equipment is less, but lower processing costs as well, because you don't need as much energy. But the other crucial thing is that what we do is we go from the waste product, the paste in a dead battery, and we convert it to lead oxide for use in new batteries in one step. So we do not handle an intermediate piece of lead metal, the metal you have to melt and reprocess. We skip that stage completely. We call it from waste to paste. So we take the waste paste and we convert it to new paste.
And so being 2-to-1 in terms of energy, it is viable in terms of as far as the economy is concerned?
As far as the economics are concerned, it's
can
fantastic.
companies survive only by making recycling of lead batteries through your new technology?
Well,
suppose tomorrow we decide to build a company and do just that.
It's a very profitable industry, and the growth of the secondary lead acid batteries forecast to be something of the order of $84 billion by 2025. That's for the secondary lead acid battery. The recycling of the battery, which is the revenue stream sitting inside that larger sphere of the battery, is something like $14 to $16 billion globally. But if I can go back to the benefits of using water rather than fire, because energy is just a small part of the overall benefits package, and it's not usually the strongest selling point for this technology. One of the greatest benefits of doing this in water and going from the waste material to the oxide directly is that you essentially cut the carbon footprint by anything from 80 to 89%. It is a massive reduction in the carbon footprint. In terms of the slag that the incumbent industry produces, if they take the paste and they move it through our process, and the rest of the battery they process through their current system with the pyrometallurgy, because that's what you need for the plate, the grid and everything else, the amount of slag that they produce would be reduced by more than 90%. And the slag is normally landfill. So again, this is a massive improvement in terms of the green credentials. The energy cost is very low. In fact, a key stage in our process is actually releasing energy rather than consuming energy. And this is because when we carry out the process in water, we isolate a material that then leads to burn. And when I say burn, I don't mean the same as the pyrometallurgical burning where you fire up the furnace and you have to keep it burning at a certain temperature. First of all, this burns at a lower temperature. It's more like 350 to 400 degrees. And second, it sustains its own heat. It burns exothermically. You ignite it.
Productivity of the process.
In terms of
Recycling per month, per day, any number. How much you can recycle?
Well, what amount? Well, we've tested the process at a 1 ton an hour setup. We're building commercial plants that can do 25,000 tons per year capacity. And I believe ultimately you'd want to be making anything from 1 to 10 tons an hour, depending on the capacity that you have. But it's all very scalable, and that's part of what we have been doing in the last 2 years.
Because it's hydro.
Yeah.
Because hydro, normally has been around for some times, but the idea is never achieved. At least there are many people claiming that hydro never achieved the efficiency of the pyro in doing anything. So what do you think about that? That's the idea, circulating around.
But there's definitely an element of truth in that. I mean, pyrometallurgy has always been the king of refinement. Fire can do metal so much better than water. Now, the reason our process and technology is economically, environmentally, technologically viable is not because it sets out to replace pyrometallurgy. It's because our objective is to make pyrometallurgy better. We are taking away that one thing, the battery paste, that they shouldn't be burning because it's too expensive to burn, it's too polluting to burn, it produces too much slag, and we are saying that you can put through water and we can make not metal, but metal oxide for use in new powders. And as for the rest of the battery, carry on, do what you've always done, and you will be cleaner, more energy efficient, and cheaper as well.
You are the Chief Technology Officer, correct?
Yeah.
And this is your main job to determine how viable are the technologies dealing with waste and batching, using waste as a primary materials between industries, correct?
To a degree, yes.
There's much more than that.
I would say, well, we are first of all, we're a team of people.
Okay.
There's people at university who are very good at inventing, doing their fundamental science and coming up with new ways of doing certain things that may or may not have application in industry. And as a company, and especially for myself as CTO and my CEO, who is a former director from GMP Batteries, we basically devise an R&D strategy for the company. We have this great big think bubble sitting at the very top where we say, we have these ideas, these technologies, these problems that are somehow related. And it's not always simple to know what the solution is for any of those problems. We may go to some place.
That was my question.
And we find something and then realize that it's connected to a problem and in some cases the problem may be a problem that the industry doesn't even recognize as being a problem.
Yes.
For example, take the battery paste, for example. A lot of smelters will tell you, but the battery paste is so easy to recycle. All we do is we burn it at 1,000 degrees and we make lead metal. So actually it's not a problem. All it does is it releases a lot of carbon dioxide and sulfur dioxide that we can catch. So these problems are not necessarily recognized as being problems in some cases.
Yeah, sure. Well, that's basically true. It's abnormality sometimes becomes normality within smelters and within many other companies. But as a Chief Technology Officer, you love your job.
Absolutely.
Better than you're also a patent attorney.
Well, once upon a time, I was training to be a patent attorney. I'm the sort of person that likes to self-reflect a lot, and sometimes I find it quite surprising that scientists, scientists are the masters at asking questions. Sometimes questions that nobody wants to hear. They look at data, and the data tells them something and they're challenging the norm, or they may set out to do an experiment, they get the results, they realize the experiment is wrong, and they change what they're doing. But sometimes when it comes to ourselves, our career options, what we do in life, we perhaps as scientists are not as good as evaluating decisions we made a long time ago.
Decision, you mean?
Decisions in terms of what direction we want to take in life and in business. And I'm the sort of person that does self-reflect and reevaluate decisions that I made in the past. One thing I knew for sure when I was a kid is that I was going to study science.
How?
You know, I was, first of all, I was one of those kids that was always going around with a screwdriver destroying things. And that's very important actually, never fixing things, always destroying them. Because I was interested in how things work. I remember, for example, one of my earliest memories destroying things at home was a telephone. I couldn't quite understand how it is that Grandma's voice was coming out from the speaker. You know, I wanted to find out, and somehow I thought that if I open up the device, you know, the secret will be revealed to me, which wasn't really. All I did was destroy a telephone. But it's the same with growing up. I wanted to understand how things work, whether they're biological systems, whether they are mechanical devices. And so for me, the question was not science or not science, it was which kind of science. And in the end,
I crossed your mind to be a lawyer.
Well, so I decided it had to be science because I wanted to understand how things work. Scientifically, that is. I mean, obviously, sociology and other social science subjects allow you to understand how things work in a different way. But I decided it was going to be chemistry because it's quite fundamental. I was looking at the periodic table and thinking, well, you know, biological systems are complex, but there are small molecules underlying what is happening there. Physics is fascinating as well, but there are particles and atoms that determine what happens there. Luckily, back then, I didn't realize that you can split an atom and an electron into various different constituents, because if I did, I would probably have said, okay, physics is more theoretical, so I should go down that route.
But
I went
whether
with
it's chemistry or physics, none of any other choice.
Well, it was, we were not spoiled for choice, but then actually...
We're speaking with, just give me a reference in time.
In a reference in time, well, that was the late 90s.
Late 90s.
And it was,
late 90s.
Yeah, and it was quite a small school that I had attended. They were not quite as big and flashy as some of the schools I'm taking. My 3-year-old now, 2.5-year-old, and we're looking at schools and I'm seeing the facilities they have and the choices in subjects. We were not as spoiled as in choice as he had been a couple of years.
If you would have had literature, law, sociology, and actor, you would have chosen any of those?
Well, I think actor is not the kind of career you choose. It's a career that chooses you. There's some people who are very talented in that and very photogenic and very athletic. Perhaps they go down a different road.
Not in the sense that people fight to be an artist. Actually, it's not easy, but that's the concept. It's around.
It can't be easy.
Wow.
Nothing.
The new generation thing is easy, but a different story. So, and their concept about science is that it's boring.
Well, look.
And engineering, you go around and take the waste, and then you recycle the waste, and then you're going to say, well, what's fascinating about recycling waste? Why should you do with waste?
Well, let me tell you about that.
So how you can counteract it?
Well, before I tell you how I think you can counteract that, I can tell you that I can understand why a lot of people become disenfranchised with science. And I can say that because it actually happened to me as well, which is why I moved into intellectual property law. Because I'm going into university from school and doing a general degree in chemistry, a bachelor's in chemistry. I felt, I would take on the world. There's all this knowledge out there and I'm going to go there and have so much fun, and I did. And I absolutely loved it. And then I went into a PhD. And I realized that the more advanced you become as a scientist, the more narrow and niche your science becomes. And I tried to battle against that. I was going to research groups. I was in Cambridge University in the chemistry department, and I was going around other research groups and getting myself introduced to other professors and attending their group meetings and trying to consolidate all this knowledge from all these different groups who were working on completely different things.
And what happened?
What happened was I realized it's impossible to do. Because the literature, it's like an abyss, and every day they produce so much amazing science, and the more you go into it, the more that hole becomes narrower and narrower until eventually you become a total expert in a very, very small field. And I thought to myself, this is not what I signed up for as a scientist, or perhaps this is not what I want for myself as a career. I'm more fascinated by
What was your concept about science?
What I wanted
Before signing up?
was to see science and technology making a difference in the world. And that's not, I mean, it all starts from the laboratory. If you don't have the scientists who are gonna go to the lab and invent processes that in 10 or 20 years are gonna change the way industry works, that's where the innovation begins. However, I was more fascinated with seeing the technology make that leap from the laboratory to the industry and scaling it up and optimizing it and making sure that it adds value and it solves problems, and then seeing it penetrate the industry and improve things. And naturally at the time, I thought, well, that means it's clear to me what I have to do. I have to become a patent attorney. Because that will take me closer to technology and innovation, and I will see the technology that's important in a commercially confidential way, and I will be involved in protecting it and helping a company take it out there and do great things with it. And of course, to a degree that's true as well. And I started my training, and I loved learning more about law and about designs and patents and trademarks. But as I became part qualified, again, I've self-reflected, and I thought, actually, I think technology transfer is perhaps more where I should be as a scientist and as a professional.
How came to your mind this change?
Because it's technology transfer is more about taking technology from laboratories and de-risking it and working more closely with industry. And of course, part of that process does involve getting patents for the technology and administering its intellectual property and using that commercially. But you don't necessarily draft the patents.
Then you change your mind again.
Yeah, so I'm in technology transfer, and from there, my exposure to technology transfer was actually very brief. I was at Cambridge Enterprise, the technology transfer arm for the University of Cambridge, but I only stayed there 6 to 8 months before moving to industry with the very technology that we're using now, which was at the time part of the portfolio of the University of Cambridge, and they were looking for companies to commercialize it.
So you're just so passionate about this. So I see it, you continue. If I leave you going, you might be here for an hour or something. But just
possibly.
Because I see the passion. But just to change a little bit the gears, besides dedicating to this new technology transfer, what are your hobbies?
Hobbies as in life outside work?
Yes.
Well, I am, believe it or not, I'm quite privileged in that I can work from home a lot. Okay. We have a factory in Dudley, Tipton in the UK, and our research arm is in Cambridge, and I'm somewhere between the two. So usually I spend a day in the university whenever I can. Most of the time I have client meetings or expressions of interest to go to, so I tend to travel a lot. But when I don't have any of that, I work from home, and it's fantastic because I have a 2.5-year-old, and it's great to spend more time with him. So I wouldn't say.
How much time you spend with him?
I wouldn't say there is a balance between life and work. The two are kind of integrated at the same time and go from one to the other. Constantly. A lot of times I speak to clients or collaborators while I'm driving, and my son's at the back singing. And somehow I haven't lost my sanity.
That's good. There's nothing wrong.
No,
with it.
it's a lot of fun. I mean, I used to be involved in other things as well. I was a member of a jazz band at the university, so I used to play bass guitar and piano, but I don't have a lot of time to pursue that anymore. And I have to say that in that regard, that it's not as if a lot of people in technology, I know we have a bad reputation for working hours. A lot of people work 7 to 10, as in 7 a.m. to 10 p.m. But the truth is that nobody's forcing us to do this. We love what we do so much that time just flies. And it's just the name of the game.
Well, that's a good way to put it. What about your son? He asked you 2 years and a half. Did he ask you what he wants to be in the future?
Well, he hasn't. He's not at that stage yet. But as far as I'm concerned, it's his choice.
Engineer, scientist.
Actually, I would love to have some kids who are more into art and music. I mean, I wouldn't push anyone to go into any direction, but I feel anything anybody wants to do, I would support my children to do what they want to do. And obviously,
that's fine.
Science, technology happens to be my field, and as parents, we always want what's best for our kids. But sometimes. We have to take a step back, and I'm not saying this as an experienced parent because my kid's only 2.5 and I've only got one. But I feel that I can't wait to find out what sort of things light up his world, what he wants to do. And I think sport, art, and music, these are things that I wasn't personally exceptional in any of these things to have a career out of them, but nevertheless, they're amazing skills.
There is an expression that parents never want their children to follow their profession because they know the bad side of their profession.
That might be true because every profession has challenges and problems, and life is a journey, and you go through stages of disappointment and difficulties. But it's those dark periods that make you who you are and forge your personality and your ambitions. So I think it would be a mistake to try and enforce certain ideals we have on children. But nevertheless, we are there to advise when they need us. And if they tell us, Daddy, what sucks about your business? I have a whole list of things I can share with him.
Yeah, that's true. No, the question is because science and technology is in a good position as it used to be currently, so that's why the question. If you go back 30 years, do you have any regret? Would you have chosen a different field, a different direction? You would have been better at patent attorney or engineer, or if you are at level 0?
Honestly, and I know this is going to sound cheesy, if you asked me this question 4 years ago, I would have come up with a list that was 90% regrets and only 10%. But because I was still in that stage where I thought, I've done chemistry. I was pretty good in the laboratory as a researcher. Why on earth did I get away from that to become a patent attorney? And actually I did pretty good in my qualification exams. Why couldn't I see that through and become fully qualified? I think the problem is I did chemistry, I should have done electrical engineering, there's more business for patent attorneys, maybe I shouldn't have done this, maybe I shouldn't have done that. Fast forward to today, and I've taken up quite a unique position in the industry, because as being a part qualified patent attorney, I work very closely with my patent agents to write the patents. And I know the sort of things we're looking for when I see the inventors in the laboratory who invent those things. And I look at my present situation and thinking I've managed to consolidate my skills and help industry in the best way that I can. And I feel today, I honestly couldn't tell you that I have any regrets in terms of what subjects I pursued at university. If I had to pick one thing, I would say as a student, I focused too much on organic chemistry, reaction mechanisms, biological organic chemistry, and I did far too little electrochemistry and metallurgy. And those are the two subjects that I use the most in my company today. They're not completely alien to me, but I would have liked to have picked more options in electrochemistry and metallurgy.
Not in the other field. Still in where speaking.
No chemistry.
Chemistry, science is exactly.
Oh yeah, science. I think science is for me for sure. It's the thing that gets me out of bed. I will other than my kid, of course. And I mean that in a great way, not because he wakes up before I do. Science gets me out of bed, and I love doing science and using science to solve problems and making industry better and human lives better. Behind every amazing innovation that we enjoy today as a species, there is a laboratory. Maybe it was a laboratory centuries ago in ancient Greece or God knows where, but more recently as well. People invent amazing things, and those things become our future. And I can't think of myself working anywhere else.
That's great to hear. Meaning, it is fun.
Oh yeah,
it is fun.
Absolutely, it is fun.
Thank you.
How can it not be?
Thank you. It's a very pleasure to speak with you. Very insightful.
Thank you. I appreciate it.
Thank you.